Assalamu alaikum and welcome to Integrity Studios. Today our topic is waves. Waves is a very crucial part of A-levels physics. So without any further delay, let's start. Today we will be looking at basic waves. Now, the first thing is, what do we understand by the word wave? Okay, let me simplify it. A wave is the transfer of energy through a medium or vacuum. Now, this part is interesting. This part is really interesting. What do you mean by through a medium or vacuum? Okay, a wave is just the transfer of energy from one point to another, but it depends on the type of wave if we need a medium for the wave to travel or not. So, how is that determined? Depends. There are basically two types of wave. There is transverse wave, there is longitudinal wave. Transverse waves do not require a medium. On the other hand, the longitudinal waves require a medium. The best example of a transverse wave is light. As it does not require a medium, it can travel through vacuum. Light travels to us from the sun through vacuum. So it is a best example for transverse wave. What about a longitudinal wave? The best example is sound. Sound always requires a medium, either air or a solid medium or a liquid medium, but without a medium, sound cannot travel. You cannot hear sound in a vacuum because it cannot travel through a vacuum. Now, how do we separate transverse wave from longitudinal waves? For that, we have to bear in mind two things. One, direction of motion of wave, which can also be written as direction of energy, and the direction of propagation or oscillation of the particles. I'm really sorry about the handwriting. So let's see a simulation. Here we can see there is a green dot in the middle at intervals. If we just play it, we can see that only the green part is moving up and down, not left and right. What do we understand? But the wave is traveling to the right. So this is the direction of the motion to the right, and the up and down is the direction of propagation of the particle. The particle is not actually moving from its initial place, it's just propagating up and down, or just propagating us in a small range of area, and the energy is traveling. So for a transverse wave, we have to always remember, in a transverse wave, this is the direction of wave or the direction of transfer of energy. This is the direction of oscillation of particle. In transverse wave, the direction of oscillation of particle is perpendicular to the direction of movement of wave. In a longitudinal wave, longitudinal waves normally create a number of contractions and rarefactions. Now this is what we mean by contraction and rarefaction. This part and this part is a contraction. This part is a rarefaction. As you can see, the distance between two waves is greater in this part than here. So in this case, the particle which is at this point is actually moving left and right, hitting other particles on its left and right, which is hitting the next particle, causing the energy to transfer all along. For this, the direction of movement of energy and the direction of propagation of particle are parallel. So, for transverse wave, the direction of oscillation of the particle is perpendicular to the direction of the motion of the wave. For a longitudinal wave, the direction of motion of the particles is parallel to the direction of motion of the wave. Is this clear? This is what we understand by basic waves. The next topic is mostly reflection, refraction, and diffraction, which falls under the light wave. Then there is a detailed explanation of light and sound, and also some advanced concepts such as superposition and standing waves. Those will be coming along sometime later. For more videos, don't forget to like, share, and subscribe. So that will be all for today. Signing off, Integrity Studios.